Hello students, today we are going to see some questions of ionic equilibrium. So question number 1 is there. Calculate the number of H plus ions in 1 cc of a solution of pH 13. So see, as you can see, pH is given 13. pH formula is minus log of concentration of H plus ions. Now this is given 13. So you will calculate here concentration of H plus ions will be anti-log of minus 13. So this will go in the power 10 raised to power minus 13. Okay, now it is given in 1 cc. 1 cc here concentration is 10 raised to power minus 13. Volume, if you will calculate, volume here it is given 1 cc. That means it is given 1 ml. So if we will calculate in liter, that will be 10 raised to power minus 3 liter. Okay, now volume we are having, concentration we are having, we can calculate number of moles. Number of moles is equal to molarity into volume. So molarity is 10 raised to power minus 13 and volume is 10 raised to power minus 3 liter. So total moles will come 10 raised to power minus 16. Okay, now what question is asking is total number of H plus ions. So we know in 1 mole how many numbers are there, how many number of ions will be there, Na, that is Avogadro number 6.023 into 10 raised to power 23. Okay, now we have how many moles, 10 raised to power minus 16 moles. So total number of H plus ions will be there in solution, that will be equal to 10 raised to power minus 16 into 6.023 into 10 raised to power 23. So as you can solve, you will get 6.023 into 10 raised to power 7 you will get. So this will be your answer. So basically some concept of pH we are applying in this question and some concept of stoichiometry we are applying, mole concept we are applying in this question. Now next question, question number 2. The pH of a HCl is 5. It is diluted by 1000 times. Its pH will be. So options are given. Pause the video students and try this question once. Now we will solve the question. See, pH of HCl is given 5. Again minus log of H plus will be 5. So concentration of H plus will be anti-log of minus 5, that will be 10 raised to power minus 5. Okay, now we are diluting it by 1000 times, that means we are decreasing the volume. Okay, so per unit volume will be decreased. Okay, how many times? 1000 times. That means concentration, see, concentration is nothing but number of moles per unit volume. So if volume you are increasing by 1000 times, okay, so what will happen to concentration? Concentration will decrease by how many times? 1000 times. So that means final concentration of H plus ion will become 10 raised to power minus 8. Okay, now this is very diluted. Okay, very diluted solution. Now we know, see, H2O at room temperature, it will also show dissociation, H plus and OH minus. Here 10 raised to power minus 7 moles of H plus and OH minus ions are there, and H2O at room temperature it is neutral. Okay, both ions, both H plus and OH minus concentrations are equal. Now but when solution is that much diluted, we need to consider these H plus ions also. So if you will calculate total H plus ion, total H plus ions are 10 raised to power minus 8 plus 10 raised to power minus 7. So we can take 10 raised to power minus 7 common. Here it will be 10 raised to power minus 1 plus 1. So total you will get 1.1 into 10 raised to power minus 7. So that will be total H plus ion. Okay, now pH you will calculate. pH is minus log of H plus ion. How many H plus ions are there? 10 raised to power minus 7. 1.1 into 10 raised to power minus 7. Log 1.1 is student 0.04. Basically this value they will give in question only. Here it is not given, so I am giving you log 1.1 is 0.04. So here we will calculate minus log 1.1 plus minus log of 10 raised to power minus 7. So this will be minus 0.04 plus log 10 raised to power minus 7 will come minus 7. So minus 7, okay, that will be our plus 7. So from here you will get 6.96. So pH of this solution is 6.96. Okay, so which option will come? Option D will come. Okay, so pH value is in between 6 to 7. I hope you have understood this question. Okay, now we will move to our next question. The pH of buffer solution prepared by mixing 50 ml of, write it down, 50 ml of 0.2 molar CH3COOH acetic acid and 25 ml of, see, nothing is given. Okay, nothing is given. Concentration of salt is not given. So let's say we will take it as x molar. X molar sodium acetate. Okay, CH3CONA. So from here we can calculate moles of acetic acid, moles, molarity 0.2 into volume in liter, so that will be 0.05. So it will come 0.01, that is 10 raised to power minus 2. Here moles of sodium acetate, that is salt, that will be equal to again molarity x into volume in liter. So it will come 0.025 x moles. Okay, these are number of moles. So moles we have calculated. Now one more thing is given in solution. As you can see, students, pH of the buffer solution is given 4.8 as well as pK of acetic acid is given 4.8. That means according to our question, pH is equal to pKa. According to our question, pH is equal to pKa, and we know students that this is the condition of maximum buffer capacity. Okay, this is the condition of maximum buffer capacity. And when this maximum buffer capacity condition applies, when salt upon acid ratio is 1. Okay, salt is to acid ratio is 1. Now here we have taken concentration. These are number of moles. If you will calculate total volume, that will be equal to 50 plus 25, that is 75 ml, that will be 0.075 liter. Okay, so now concentration of salt, so that will be 0.025 x divided by 0.075. Okay, we are doing salt and acid ratio. Okay, so upon, now acid is 10 raised to power minus 2 moles divided by total volume 0.075. So this will cancel. You will get 0.025 x divided by 10 raised to power minus 2, that will be equal to 1. So x will be equal to 10 raised to power minus 2, 25 into 10 raised to power minus 3, or you can write 10 upon 25. So it will come as 0.04. So which option will come? Second option will come. So in this question, basically first we need to calculate moles. Okay, we will assume the molarity of the salt is x, and at the end we have to calculate concentration of sodium acetate only, so concentration of salt only. So we will assume it as x and we will do the calculation part. This most important thing you need to remember here is this condition for maximum buffer capacity. When pH is equal to the value of pKa of acid, that time maximum buffer capacity condition is there, where salt is to acid ratio is 1. That you need to remember. So I hope all the solutions are clear to you students. Thank you. Have a nice day.